The reteach today is going to go through each question on the test and fully explain how to do those problems and maybe give you some little tips and alternate ways to do these that'll maybe make it a little more efficient. The first question asked us to find the y-intercept, equation of the axis of symmetry, and the vertex given the function f of x equals 2x squared minus 4x plus 1. An easy way to know how to graph this without putting it in the calculator straight away is to complete the square to get the equation in vertex form. So the first thing you want to do is isolate the x squared term and the 4x, and notice that you can actually factor out a 2. So I put the x squared and x term in parentheses, and I actually factored out a 2 just from those terms. Notice the c, or the y-intercept, is exactly the same. Now what I want to do is I want to complete that square. I want to fill in those blanks. So remember, I take half of b and then square it. So half of 2 is 1, and square 1 and you get 1. But I've added something to that equation, and when I add something to the equation, I have to make sure that the equation is still balanced. So what I really added to the equation was this 2 times 1. So I really added 2 to the equation. So to keep it balanced, I've got to subtract 2. Now I just need to simplify a little bit. I know that this perfect square trinomial factors to be x minus 1 squared, and positive 1 minus 2 is negative 1. Now from this vertex form, I can tell a lot of things about this graph. First, I can say that the vertex is 1, negative 1. I can also tell that it opens upward because the a is positive, and I also can tell it has a vertical stretch of 2. The y-intercept is 0, 1. Get that from the c value of the original function. The axis of symmetry comes from the x value of the vertex for a parabola with x squared. And so the graph, we have 1, negative 1 is our vertex. We have 0, 1 is our y-intercept. We'd be able to graph our axis of symmetry straight through that vertex, vertically through positive 1. For these next problems, we are solving by factoring. Remember, when we're factoring, we have several different methods. The first question we have here is the factoring method where a value is equal to 1. So we're just going to be looking for factors of negative 21 that are going to add to negative 4. So factors of 21 are 1 and 21, 7 and 3. The combination that's going to work for this one is a negative 7 and positive 3. In order for this to be equal to 0, one of these factors has to be equal to 0. So I set each of those factors equal to 0 and solve each of those for their x value. Subtract 3 and you get x equals negative 3. So add 7 to both sides and you get x equals 7. So our solution set for this one is negative 3, 7. This next one is a little more complicated because our a value, or the coefficient of our x squared term, is not 1. So in this one we have to factor by grouping. So the first thing we do is multiply a and c together and we get negative 30. Then I'm looking for factors of negative 30 that are going to add to 7. So what I do is I break up that middle term into those factors. The factors of 30 that are going to add to positive 7 are going to be positive 10x and negative 3x, would give us 7x. Now I'm going to group my first two terms together and my second two terms together, and I'm going to factor by grouping, which means I'm going to pull out the greatest common factor from each group. In the first group, we can see the common factor is 5x. When I factor that out, I'm left with 3x plus 2. In this one, the only common factor is negative 1. So when I pull out negative 1, I'm left with 3x plus 2. So notice that 3x plus 2 is the same in both, so I bring those together and have 5x minus 1 times 3x plus 2 equals 0. Now I have my factors, so each one of those is set equal to 0, and solved for x to get negative 2/3 and positive 1/5. Our next set of problems is solving by completing the square. So in this method, I'm not going to factor, I am going to complete the square and then solve. So notice that in this equation, all the coefficients are divisible by 3. So I'm going to go ahead and simplify this problem, dividing by 3 on both sides. That leaves me with x squared plus 4x minus 12 equals 0. Now I can go ahead and complete the square. I'm going to group my x squared term and 4x term together, and I'm going to move 12 to the other side. Now I need to take half of b and square it, which gives me positive 4. Half of 4 is 2. 2 squared is 4. Because I've added 4 to this side, I have to balance the equation and add 4 to this side. The reason I subtracted in the first problem is because I was working on the same side of the equation. Now I'm working on different sides of the equation, so I need to do the same operation to both sides. Now I'm going to simplify a little bit and go ahead and factor this perfect square trinomial and get x plus 2 squared equals 16. Now I notice I have something squared equals 16, so I can square root both sides. So x plus 2 is going to equal either positive or negative 4, because the square root of x plus 2 squared is x plus 2, and the square root of 16 is plus or minus 4. Now this is really two equations. This is x plus 2 equals positive 4, and x plus 2 equals negative 4. Subtract 2 on this first equation and get x equals positive 2. Subtract 2 from the next equation and get x equals negative 6. So my solution set is negative 6 and 2. Next, I'm solving by quadratic formula. It's the same equation from the previous problem. Here's my quadratic formula. I'm going to go ahead and simplify that problem and by dividing by 3 again to get me x squared plus 4x minus 12 equals 0. So now my a, b, and c are 1, 4, and negative 12. Now I can plug those values in to the quadratic formula. When I first plug those values in, I get negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now I need to simplify things. I can have 4 squared, which is 16, minus 4 times 1 times negative 12 gives me a positive 48. So 16 plus 48 gives me 64 in that radical. And I have negative 4 plus or minus the square root of 64 divided by 2. Well, 64 is a perfect square, so I can take the square root of that and get 8. So I have negative 4 plus or minus 8 divided by 2. And I still get 2 and negative 6, just like I did when I solved it by completing the square. The solution should not change when you're just using a different method to solve it. Now we're looking at imaginary numbers. The important thing to remember with imaginary numbers is that there's actually two parts. We have a real part and an imaginary part. So in Z, the real part is the 4, the imaginary part is 5i. We have W, the real part is 3, and the imaginary part is negative 5i. So when I'm performing operations with those, we treat those I terms kind of as variables. We have separate terms that we can't combine. I can't combine 4 and 5i. What I can combine when I'm adding is real with real, imaginary with imaginary. So I have 4 plus 3 and 5i minus 5i. Those cancel out and I'm just left with the 7. For z minus w, I'm subtracting that entire expression, which means I have to distribute that negative. So I'm going to have 4 plus 5i minus 3 plus 5i, because when I distribute that negative, this becomes positive. Combine your like terms. 4 minus 3 is 1. 5i plus 5i is 10i. So I'm left with this complex number with the real part of 1 and imaginary part of 10i. Now I'm going to multiply those two together. When I'm multiplying these, I treat it as if it's a binomial times a binomial. So I'm going to FOIL my first terms, outer, inner, and last. So first gives me 12, outer gives me negative 20i, inner gives me 15i, and last gives me negative 25i squared. But remember your powers of I squared is really negative 1. So that becomes a positive 25. Now I can just combine like terms and have 37 minus 5i. Next I'm going to be dividing. So I have 4 plus 5i and 3 minus 5i. But having that imaginary term in the denominator is kind of a no-no. We want to fix that. So I need to multiply by the complex conjugate. The complex conjugate of a complex number, when we have a minus bi, is just a plus bi. So we're going to multiply by the complex conjugate of just the denominator, because that's the part we want to get rid of. So I'm going to multiply by 3 plus 5i over 3 plus 5i. Notice that this really just reduces to 1, so I'm not changing the expression at all. It's just going to change what it looks like. So now I'm going to FOIL the top and FOIL the bottom, and I'm left with 12 plus 20i plus 15i minus 25 over 9 plus 25. Now just simplify your like terms, and we have negative 13 plus 35i divided by 34. To graph these, you need to look at each real part and imaginary part. In the complex plane, the real axis is your x-axis, and the imaginary axis is the y-axis. So the real part is like your x-coordinate. The imaginary part is like your y-coordinate. So I will go over to 4, up 5, and make that vector line, and there's my imaginary number graphed. For 3 minus 5i, the real part is like my x, the imaginary part is like your y. So positive 3, negative 5, and there's the point where that imaginary number will be. Next, I'm looking at powers of I. Remember, I to the 0 is 1. Anything to the 0 power is 1. I to the first is just I. I squared is I times I, which is going to be negative 1. I cubed is negative I. And then notice we return back to I to the fourth equals 1. So the way to look at a problem like this with a big power of I is to divide that exponent by 4. Notice after 4 rotations, we get back to 1. So if I divide that exponent by 4 and look at the remainder, that 0.5 tells me that I have a remainder of 2. So if my remainder is 2, then I to 9,514 has to be negative 1. Next, I want to write this equation in standard form. Standard form is really the vertex form of the equation. So I'm going to be completing the square in order to do that. So again, isolate your x squared term and your x term. And then just write your c value off to the side to leave some space to complete the square. So half of b squared is positive 25. But since I added 25, I've got to subtract 25 on the same side of the equation to keep the equation balanced. Now I'm going to factor that perfect square trinomial and combine like terms here. Now I have the vertex form of the equation, and I can see the vertex is negative 5, negative 23. For this next one, we're asked to find the direction of opening, vertex, axis of symmetry, focus, directrix, and the length of the latus rectum. First, let's talk about the way this parabola equation looks. It's a little different than what we've dealt with prior to Algebra 2. It's y squared instead of x squared. So it's going to look like this type 2 parabola that opens either right or left. Notice the vertex form is a times y minus k squared plus h. So the h and k are actually in different spots on those vertex form equations. Our vertex is still h and k. They're just in different spots in that equation. The axis of symmetry is y equals k, which is the y value of the vertex. And then our equation to get the focus is h plus 1 over 4a comma k. In this equation, we notice that our a value is positive, which means that this is going to open in the positive direction. For the left and right parabolas, positive is always to the right. So we know that this parabola is going to open to the right. In this equation, we can see that our k value is going to be -2, and our h value is going to be +1, so our vertex is going to be 1, -2. Our axis of symmetry is going to go directly through that y value of the vertex, so our axis of symmetry is y equals -2. The focus, we can actually look at the graph for this one. The focus of this one is h plus 1 over 4a comma k. So our a value is 1/4. If we have 1 over 4 times 1/4, 4 times 1/4 is 1. So 1 over 1 is 1, plus our h value of 1 gives us an x value of our focus of 2. K stays the same as the vertex because it's along that horizontal axis of symmetry. And so 2, -2 is our focus. To get the directrix, which is actually the equation of the line through that point, that is the same distance away from the vertex as it is from the focus. So the vertex to the focus here is 1 unit away from 1 to 2. So we have 1 unit of distance from the vertex to the focus. So I'm going to have 1 unit of distance on the other side. So 1 unit of distance from 1 is 0. So you can see this blue line here. That is going to be our directrix, which happens to be the x-axis here. So our equation for the directrix is x equals 0. In this last problem, I need to write the equation of the parabola with a focus 3, 2 and a directrix of y equals 8 and then graph. So we're actually going to work from the graph, and it would be easiest if you would sketch this problem first to understand what direction that parabola is going to be going and what points we need to solve for. So first I plotted the line y equals 8, which is a horizontal line through +8. And then I plotted my focus, which is at 3, 2. The key to knowing the directrix and the focus is that we know the vertex of our parabola is exactly halfway between them. So notice I've plotted this little blue point here. That's exactly in line with that vertex. I know that my vertex has to be between those 2 points. So I'm going to find the midpoint of that and get that my vertex should be 3, 5. Now this actually tells me a lot about this parabola. I know the vertex is here. I know my focus has to be inside the parabola. So I know my parabola is going to open downward. So I know my a value is going to be negative, but I need more information to be able to solve it. So I'm actually going to use the equation for the directrix to help me solve, which is y equals k minus 1 over 4a. I know the y value of the directrix is 8. I can use that value and substitute it in for y. I now know the vertex has a k value of 5, so I'm going to use those two values to be able to solve for a. If I do that, I get a value of a equals -1/12. So I can see according to this graph here, I have the equation y equals -1 over 12, which is my a value I solved for, times x minus 3 squared plus 5, using that h and k value that we solved for using midpoint. So this is the graph of our parabola that we used the directrix and focus to find.